All right, gang, Math 6620. The purpose of this video is to run a multiple regression analysis and show you how I would write up the results. Now, the interesting thing about writing up the results with a lot of moving parts, as we have with multiple regression, is that, variety of styles. So there's nothing perfect about my style. It's just well, I'm your professor, so I feel like I should share it with you. The data set that I'm going to demonstrate this with is called state assessment. You'll have access to this, and let's see, the purpose would be to predict state score from end of assessment, age, SES, gender, and private. So what we have is we have two quantitative predictors, and we have three categorical predictors. And you can see that we're not going to have to worry with dummy variables because SES, gender, and private school are all dichotomously coded. So the first thing I want to do is prepare the data. Specifically, I want to set up the categorical predictors and set the baseline. So I set socioeconomic status, and I set the baseline as no. So I renamed SES, or well, high SES as just SES. The next thing you can see that I did, I jumped around. Don't be concerned with this just yet. What I was doing there was trying to see which one had the most, which gender had the highest count. So when I relabeled it, I took the one with the highest count, male. Private school, I wasn't worried about that because I knew that I wanted no to be the baseline. And again, the baseline here, the reference, is just which level do I want coded as 0. And we talked about that in previous videos. Next thing I did is I want to be able to present the count and the percentages. So I ran it for gender, ran it again for SES, and ran it again for private school. Next thing I did is I ran a box plot for state, a box plot for end assessment. I believe there was one outlier for end assessment, but I didn't concern myself too much with that. And let me show you why. I think it's worth a lot going on here. Let me go all the way up and take a look at this. Let me show you why. I believe it was end assessment. Yeah, there was one outlier, but there wasn't a lot of separation there. And overall, we have a pretty symmetric distribution. So not a cluster of outliers where I thought that there should be any deletion of cases or a case. So for the most part, I get down to this point where I'm going to proceed with the model, which I did. And interesting result. It turns out every single predictor, including the intercept, was statistically significant. End assessment and age and socioeconomic status were significant at the 0.001 level, and gender and private school status significant at the 0.05 level. And we have our, of course, get our model diagnostics down here. Now, just to review, if we're going to interpret the SES yes, so if we're going to interpret this coefficient, I would say the controlling for the other predictors in the model, high socioeconomic status students scored on average 1.22 points higher on the state score than low SES students. So, yeah, okay, well, is what it is. Next thing I would want to be able to interpret is the adjusted R squared. Remember, we have tunnel vision on the adjusted R squared when we have multiple predictors. So we would say that 85.9% of the variance in state is explained by the regression on the 5 predictors. Next thing I do is I transition into the assumptions. So the first thing I want to look at is the autocorrelation or the independence assumption. Remember the test statistic we hope is close to 2. So we have no concerns with independence. Next thing I look at is multicollinearity. No concern with VIS. as long as none of these are above 10. 10 seems to be the threshold. Next thing, as we've done many, many times before, looked at a GGQQ plot using the GGPUBR package with R. And then I ran the normality test on the residuals, which are not statistically significant. So let's wrap up what happened over here. So I'm not going to read this to you, but the first thing I did is just describe the multiple regression model that I created. And I talk a little bit about missing data, and luckily I had no missing data here. And I talk about adequate sample size. We have what, 6 predictors? 2, 3, 4, 5. Actually, we have 5 predictors. So 5 times 15 is 75. So sample size is 725. Easily meets that that threshold. And then I just come in. Always in the first sentence, you should present to the reader, the statistical software package that you use. Now, the next paragraph, what I did is presented the results that I just ran over here. So I get into a little bit about independence, normality of error terms, equal error variances, and multicollinearity. And I just go through and report the Durbin-Watson test, Shapiro test for normality, and some additional plots down here that we've seen before, the QQ plot with the confidence bands, and the residuals plotted over the fitted values, which gives us an idea of equal variance. Notice that we have no fanning out, just a cluster of kind of just a random cluster of points, which is what we want to see for the equal variance assumption. In other words, when I go to any of these points on the x-axis, the distribution, the spread of the points at those at each of those levels is about the same. So equal variance assumption, I feel comfortable with that. Now, the next thing I get into is I want to provide the results from the model. So I add in, there's so many different ways to do this. This is typically the way I do it. I like everything in one table. So what I've done is I've given the correlations for the quantitative predictors, and of course correlations for my categorical predictors does not apply. What I did over here is I gave the beta value, so that's going to be the coefficient, the estimate. So 1.86 for end assessment, 0.47 for age, and so on and so forth. I designate the level of statistical significance explained down here by note, by asterisk. And then I provide the standard error. See, what a standard error was, someone knows quite a bit about multiple regression techniques. What they can do is they can look at the standard error. They want to see consistent standard errors across the predictors. So if we get like a standard error of maybe, just as an example, 15 whatever for one of these, then there would be it'd be major concerns. Next thing I do is I come into means and standard deviations for the quantitative predictors. And then I come in on SES, gender, and private, and I give the count, the frequency, and the percentage. That's what I did. The reason I did all of this above. One thing I did forget that should be added into this would be the mean and the standard deviation for state score. And I think I would probably, yeah, I don't know. I would probably add that in somewhere. I'd say I would probably add it up here. So let's just go grab that. So 64.84. And standard deviation 7.20. Yeah, again, a lot of different ways you could do this, but that seems like as reasonable as any. Uh, I always like to put on the variables, I always put my dependent variable in a row and not a column. The only reason is it sometimes gets pretty messy if you have multiple predictors squeezing in all of your uh, variables on the columns. So I always allow for the addition of the dependent variable in the row, but that's up to you. Yeah, again, you could do this a lot of different ways. Um, so I presented it this way. Um, I talk about first of all, just introduce the table and what I'm going to present there. The next thing I do is I come in and get uh, my model diagnostic. So the full model against the intercept only was statistically significant. We've talked about that in previous videos. And the next thing I would do is talk about the adjusted R squared, so the percent of variance in the dependent variable explained by the set of regression on the set of predictors. The next thing I would do is I come in and uh, add a comment about the variables that are statistically significant, the predictors that are statistically significant. And in this case, all of them emerge statistically significant. So I make a comment about all of them. And what I did here is I just presented the test statistics, so 26.5, 26.25, my bad, which we get from the t-value. And then, of course, I know the p-value. And then somewhere along the line, I got the confidence intervals. Where was that? Okay, right here. I just ran the confidence intervals for the model and just reported these values. So I think that's a pretty complete, comprehensive way of presenting the results of this study. Now, I went through all the outliers, how it leverages everything. One thing I did find, and I just kind of glanced over it, is I had quite a few cases that had high standardized residuals. I actually ran the range of the residuals somewhere. Um, yeah, the range right here. So I've ranged from negative 2.8 to 3.05. I probably would strongly consider finding the cases that were above 3 and possibly deleting them. But when I ran all the other things, nothing else really shows up of any concern. My DF betas, my DF fits, my Cook's distance, I mean, everything turned out to be uh, within a reasonable threshold. So I didn't delete any cases due to um, outliers or high standardized residuals or influential cases. So again, keep in mind, some of you are probably a lot, uh, you know, more creative than me when it comes to things like this. If you can come up with a better way of doing this, and I encourage you to explore that. But I just want to give you how I would probably write this up if I were presenting these results. Well, gang, that's all we got. I think that concludes this lesson. I can't think of anything else I'm going to throw at you. Um, so take care.